Solve the following equations by Gauss elimination method. First equation, 4x1 minus 2x2 plus x3 is equal to 11. Second equation, minus 2x1 plus 4x2 minus 2x3 is equal to minus 16. x1 minus 2x2 plus 4x3 is equal to 17. This is the given problem. So we have a 3 sets of simultaneous equations or 3 linear equations. Now first step, to obtain the solution, write the above equations in matrix form first of all. That is, see here, the 4 into, okay, I will write that also. Here you can see 4 into, so this is multiplication, you know, I think the multiplication of matrix. So first row, first column, you will get first equation. See, 4 into x1 minus 2 into x2, 1 into x3 is equal to 11. See here, 4x1 minus 2x2 plus x3 is equal to 11. Similarly, for second column, second equation, so this is important. For second equation, this is row into multiply this minus 2 into x1, 4 into plus 4 into x2 minus 2 into x3. See, minus 2x1 plus 4x2 minus 2x3 is equal to 16. So likewise, similarly, so third equation. So this is the third equation. 1 into x1 minus 2 into x2, 4 into x3 plus 4 into x3 is equal to 17. So if these are the 3 equations we have. This is equation 1, equation 2, and equation 3. All these 3 equations are written in terms of matrix form. So I hope you know this, or if you don't know, so now you might have learned how to write these equations in terms of matrix form. So I have written this in matrix form. So once you have written this in matrix form, first of all, what we have to do? So because our aim is to find the values of unknown variables, so that is x1, x2, x3. So here, for simplicity of computations, so we are not bringing this x1, x2, x3 in picture. So we are not writing it. So I have converted this matrix into 3 by 4 matrix. So initially this is 3 by 3 matrix, and this is 3 by 1 matrix. So I have written this as a 3 by 4 matrix for simplicity of computations. Now, first of all, you know, still I have written this in this form. So here, first element, so this will be named as a A11, second element A12, A13, and this as a B1. Similarly, A21, A22, as you know, I had designated. This is the general form of writing the matrix and representing the elements by these variables. So you can take x11, x12, x3, any variable. So here I have referred A, and for this matrix, I have referred designation B. So because this is A into X is equal to B. So this matrix is written in this form. AX is equal to B. So this is matrix A, and this is matrix B. So here A matrix and B matrix club together. So which is converted into 3 by 4, and similarly, so those are named by some variables A and B. So this is the general representation, because in the next thing, so because why I have written this means we have to learn in aspects of programming how we have to manipulate these variables. So that's why I have written. Otherwise, if you are solving numerical, it is not necessary to write this part. This part is not required. But when you are understanding in context to programming, so there you need to understand what is A11, A12, A13, how it varies, how it will be set into the loop. So that thing, so we will study in the forthcoming slides. So first of all, you understand. So given equations you write in the matrix form, and then so this is first step. and this is second step. Now reduce the above matrix to upper triangular matrix, because so we want to reduce this to upper triangular matrix. So for reducing this, so what we have to do? So we have to make, so this 0, and this 0. So then it becomes it converts into a upper triangular matrix, isn't it? So this, for this procedure, what we have to do? We have to apply a forward elimination method, so that we will see in the next slide. See here. So I have written in detail. So first iteration, make the elements below first diagonal elements to 0. Means so first diagonal element is this. So I want to make step by step. First of all, I want to make, so this element 0, and then this is also 0. But at a time we cannot do, so we can go step by step. So this is the first step. So I want to make this element 0. For making this element 0, so what we have to do? So we have to compute a factor first. So how we have to compute the factor? Factor for row 2, say this is the second row, so this is row 1, because we don't want to touch this row 1. So always you have to keep this row 1 as it is. So do not manipulate this row 1, and we want to manipulate row 2. So for row 2 we have to find the factor. Always factor is equal to which element so we want to make 0. This is the general the definition I am giving. So here I would like to make this as a 0. By which element it is designated? See here, it is designated by A21. So A21 upon, this is called a key element. Key element for first iteration. Key element. Why? Key element. Or for first iteration, first diagonal element. So you remember this. So whichever you find convenient in that way, so you write. So what is that element? A11. Say this is the diagonal element. Corresponds to here. So this is A11. So you can substitute now value. What is the A21? A21 is -2 and A11 is 4. So that is equal to -0.5. So now we have computed this factor. So first of all, you have to do this task. Once you have computed factor, the next, so what we have to do? So we have to make this element 0. So we have to make this as a 0. So for making this element 0, so we have to adapt some formula. So that is common for all the rows. So I have written already here. New element, so new value. So what we need here, we want to make this A-21 is equal to 0. So for that, old value, so this is A21. What is the value of A21? A21 is -2. So you can see here, this is the -2 minus factor -0.5 into A11. So corresponding element A11 into A11. A11 value is 4. Now you multiply this -2, this minus of minus becomes plus, 0.5 into 4, it is 2. So this is equal to -2 plus 2. So you will get 0. This is expected. So because this value, so want to make 0. So this we got. Similarly, you manipulate all the elements of this row, because simply we cannot manipulate one element. So we have to change all the elements of corresponding row. So the next element is 22, A22, isn't it? A22. A22 dash, new elements of A22 dash is A22. What is the value of A22? So here, this is the value of A22. It is 4. 4 minus factor. So it is minus 0.5 into corresponding element from the key row. So corresponding element from the key row is A12. What is the value of A12? It is minus 2. A12 is minus 2. So this is equal to 4 minus 0.5. This is plus into minus, again minus 0.51. So this value is equal to 3. So we have computed new value of this is 3, and its value now see here. So this becomes 0. So this is 3. Next, similarly, you compute one more parameter, third value. So that is A33 dash. So new value of this is equal to A23. What is the value of A23? This is the value of A23. You can see here, this is A23 volt minus 2 minus factor 0.5 into, so corresponding element. Here you remember this corresponding element, because A13 is this. A13 is sorry, 1, it is not minus 1. So this is 1 is equal to minus 2 minus 0.5 is equal to minus 2.5. It is, sorry, minus of minus, it is plus. There is a minus minus plus. This is, so you will get 1.5 here. This value is 1.5. Minus 1.5 it is. Minus 2. Okay. So let me check from the equation whether 1 minus 2, 4. 1 minus 2, 4. Okay, the values are same. 1 minus 2, 4. This is minus 1.5. And next last, so we have to manipulate this element also. So for manipulating this element, so the new element is minus 16 minus of minus 0.5 into corresponding element. Corresponding element from the key row is 11. So this is equal to minus 16 plus 11 into 0.5. This is 5.5. So this is equal to 10.5 minus 10.5. So likewise, we have computed all the values for the new row. So that I will represent here. See here. So this is the O. So because we want to manipulate, and now you substitute these values in this matrix. So its value is 0, and it is 3, and this is minus 1.5, and here it is minus 10.5. So now we have modified this entire row. The next task is to modify this row. So because we want to make this also equal to 0, same procedure we have to adopt. So for adapting this, you remember a equation. This equation is used throughout this computation, or this equation is used in programming also. New value of element. So any element you take from the matrix, so is equal to old value minus factor into corresponding element from key row. So the corresponding element here, I have shown the arrow. So if you are getting the idea, so my into corresponding element from the key row. So we'll call this as a key row. Corresponding element -2. See here, -2 we have taken corresponding element from this minus 1, and corresponding element it is 11. So this is corresponding element to this, so it is 4. So likewise, so new value is equal to old value minus factor into corresponding element from key row. So this formula you remember. So from this formula, so you can compute the new elements of the matrix. So don't use here. So this is note for everyone. Do not use row manipulation. Row manipulation technique. So because you can do this also equal to 0, but here the problem is, so you can row 1 is equal to, so you can use, so like this, for example, row 2 is equal to row 2 minus some multiplication is required, some multiplying factor into row 1. So like this also you can write. So this is not an exact formula I am writing here. So this kind of manipulation also you can do, but this is not applicable, or this kind of technique cannot be used for writing the programs. So here we have to solve these numerical methods. Numerical methods always follow a standard procedure or a routine. What is that routine here? So you can see this is a single formula. New value of element is equal to old value minus factor into corresponding element from the key row. So this is expected because throughout the program we can use a single formula for computation of new elements of the matrix. Is it clear? So next, so we'll target to make so this value 0. So for that again we have to perform similar kind of computations. So here you can see, so I have added this. So actually this value is minus here. So 4 minus 2, 1. So this is the new values. Now I would like to make this as a 0. Now this is third row. We have to manipulate third row. For manipulation of third row, so because we are using this as a key element, and this is key row. So remember this terminology. So we want to manipulate the elements of third row. So for that, so again, first step, so we have to compute the factor for row 3, say factor 2. So which element we would like to make 0? So which is this? So that value is 1. So now I am writing directly. So in the previous case, I have explained in detail. So which element you would like to make 0? So that element, that its value is 1 upon key element. So what is the key element value? It is 4. 1 by 4 is equal to 0.25. So this is the factor. Once you have computed this factor, next compute the new values of third row. So for computing new values of third row, so this is A3 dash is equal to old value. What is the old value of A31? It is 1 minus factor 0.25 into corresponding element from the key row. So this is the corresponding element from the key row is 4. So this is equal to 1 minus 1. So this is equal to 0. Similarly, you compute second. So this is new value of this. It is equal to old value. That is A32. A32 is minus 2 minus factor into 0.25 into corresponding element from the key row is -2. Here you write -2. Now -2, this becomes plus 0.25 into 2. It is 0.25 into 2 is 0.5. 0.5 means this is equal to -1.5. Am I right? So whenever I am doing mistakes, so you can rectify me. So similarly, third element, so the A33, so this is A33, so it is 4 minus factor 0.25 into corresponding element from the key row, so that is 1. So this is equal to 3.75. So next value B3 value is 17 minus 0.25 into B1 corresponding element from the key row, so that is 11. So this is 11 is equal to this is around 14.25. Now we got these values. We have manipulated the new values. We have computed the new values, so that I will represent here. So in previous case, we have manipulated this. Now the new value for A-31 is 0. And this is minus 1.5, 3.75, and 14.25. So we have computed the new values. The next, so this task is over now. So we have done all the elements which are present below first diagonal element. So we made 0. So the next aim is, so to make this upper triangular element, so we have to make this value 0. So for that, again, we have to perform one more iteration. So that is, I am referring this as a second iteration, to make the elements below second diagonal element. So that is A-22 to 0. So for that, see here, so this is the second diagonal element. Now for second iteration, this becomes key row. So you will remember here, this is important, and this is referred as key element. So this is most important. And now we would like to manipulate the elements of this third row again. Third row element. So we are manipulating the elements of third row element. So we want to retain this 0 as it is. So we want to make this as a 0 and rest of the things. So we have to calculate. So for that, again, we have to follow the same. Compute the factor for row 3. F3 is equal to, so which element you would like to make 0? Now already it is 0. So our aim is to make this as a 0. So this is minus 1.5. I would like to make this as a 0 divided by key element for this. So this is the key element. So key element is 3. So this is equal to minus 0.5. Next, so you manipulate again. So as usual procedure, you apply A33 dash, new element of this A33 dash is equal to A31 is old value is 0 minus factor, it is 0.5. So this is minus of minus 0.5 into corresponding element. Sorry, this is the corresponding element here. It is not this. So because this is the key row. Now second case, key row is this. So it is 0 is equal to 0 plus 0 is equal to 0. So it is remains as it is. And for second set, second computation, so A3 dash, this is minus 1.5 minus of minus 0.5 into corresponding element from the key row. Corresponding element is 3. So this is equal to minus 1.5 plus 1.5 is equal to 0. So we got this also 0. Now next, third, A33. So this is 3.75. 3.75 minus of minus 0.5 into, so corresponding element. So this is 3.5 corresponding element from the key row. So that is 1.5 into 1.5. This is equal to 3.75 point 1.5 into 0.5 is 0.75. 75 means this is 0.75, 4.5. So just a minute. This is minus actually. Sorry, this is minus. Minus this is means 3.75. 3.75 minus 0.75. This is 0.75 means you will get 3. This is 3. Similarly, so you have to compute. So this B3. So B3 value is 14.25 minus of minus 0.5 into corresponding element. So this is the corresponding. It is minus 10.5. So this is equal to 10.5 means half of the 10.5 is 5.25. 14 point, this is around 9. Am I right? Now, so we have written here. So already this is 0. This is 0 and its value is 3 and this value is 9. So now you can see, so we have converted this into upper triangular elements and the lower triangular solve these 3 0. So same thing I have written here. Now we have converted so the given problem into upper triangular matrix. This is upper triangular matrix. So I will give you overview once again. So this is like this. So I have included everything here. So I have segregated this. So here I have added x1, x2, x3, and then these are the lower triangular elements and the equation. So this is A dash matrix. So this is X and this is B dash, new elements of B matrix. Now original matrix is like this. So this matrix we have converted to so this form. So by applying forward elimination, so that how to do elimination, I have explained this in detail. And by applying a forward elimination, we have converted this. Now next what we have to do, so we have to write these things in the equation form. So first of all, we have to convert this into equation form. So you can see here. So again, same procedure. So this into this is equal to 11. So 4 into x1, 4 into x1 minus 2 into x2 minus 2 into x2. Yes. So anybody wants to ask? Yes.
Sir, next lecture link.
Hello.
नेक्स्ट लेक्चरची लिंक आली सर पुढच्या लेक्चरची लिंक
काय
आली
झाले? हा बरं 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 ठीक आहे स्टॉप करू आपण नेक्स्ट कंटिन्यू करू ओके जस्ट हे एकच एक्सप्लेन करतो एक लाइन सो नाउ यू हैव टू कन्वर्ट दिस मैट्रिक्स इनटू इक्वेशंस सो बाय मल्टीप्लाइंग 4 into x1 minus 2 into x2 and 1 into x3 is equal to 11 and second equation 3 into x1 minus 2 into minus 1.5 into x3 okay x3 is equal to minus 10.5 similarly 3 into x3 is equal to 9 so likewise you have to convert this matrix into equation forms now for obtaining the values of x1 x2 x3 you have to apply back substitution method that we will learn in the next lecture